Hello students, in this video I'm going to discuss about the activity which is based on the peer t-test. So in this particular video we'll discuss about the application of the peer t-test. So before we start with the actual activity, I'll firstly give you a brief idea about the peer t-test. So firstly, t-test is basically used as a small sample test. So the paired t-test is one of the difference of mean test, means when we are considering the two different samples. So there are two different cases we have. One, when the two samples are independent, then we use the t-test for the difference of means. And second one is when the two samples are not independent, right? So in this case the first condition is the sample size should be same, like I am considering the two samples whose sizes are say n1 and n2, but the condition is these two sample size are same, let it be equal to n. And the second condition is the two samples are not independent but the sample observations are paired together. For example, we can consider the case of we are having a set of patients, right? And we just measure their temperature, and after the medicine again we measure their temperature. So we want to check the effect of the medicine, that either there is a change in the temperature of the patients or not. Or secondly, we can in this particular activity also we have included the case when we have checked the performance of the student in certain tests, and after giving some remedial classes, again the student turn up for the test, and we'll try to check the performance of the student before and after the remedial classes, right? So before we start, firstly, so what we are actually doing in peer t-test. So the first step is, in this case we firstly consider the null and the alternate hypothesis, means we set up the null and alternate hypothesis. So what will be the null hypothesis in this case? The null hypothesis, we are assuming here that there is no difference. Null hypothesis means that there is no difference before or after the, you can, for example, I consider the case of the performance of the student in the examination. So our assumption is there is no change in the average marks scored by the student before and after the remedial classes the student turn up for the examination. And what is the alternate hypothesis or the alternative hypothesis in this case? The alternative hypothesis, we are assuming that after the remedial classes which we have provided to the student, so after that the result of the student improve, means we can say that mu1 minus mu2 is less than 0, or we can say that because mu2 represent after remedial classes the result of the student, or we can say that we have adopted some different pedagogy, okay, and on the basis of that the performance of the student improve. So the null hypothesis we can also assume like the difference of means, that mu1 minus mu2 is equal to 0. So the next step is we need to set up the level of significance. Generally we are assuming the level of significance as a 5%. Level of significance as a that is the value of alpha is 5%. So in this case because we are considering mu1 minus mu2, so basically we are assuming left tail alternative test, okay. Although in most of the cases if we refer the table t table, then generally we are given the t table for right tail only, okay. So for example, if I show you the t table, then you can see here we are given the t table as a cumulative probability, where the value of t started from 0.5 probability, because basically t distribution is a symmetric distribution like a normal distribution only, but it is more peak than the normal distribution, right? So in this case it is also symmetric about origin. So you can see here we are given one side t table only. If you just look at the figure, so in this case basically if we just draw the graph, so in that case you can understand that you are given the t distribution table for the right handed side only. So the graph of the t distribution is basically, it is more peak than the normal distribution, okay. So it has a graph like this. Okay, so in this case we are given the right handed part of the t distribution table only. You can see here the value is minimum value is 0, it is not negative, but because the t distribution table is symmetric, so for example if we want to check the value of t at a 5% level of significance, so whatever the value we have for the right hand side, so in the same manner we can calculate its value for the left hand side also by adding a negative sign with this. For example, at 5% level of significance, one tail, okay, for 1 degree of freedom its value is 6.314. okay, so if we say that for the left tail test its value is minus 6.314, this is the first thing we need to note down. Okay, so we are considering the level of significance 5% here. Okay, and the next one is the test statistics. The test statistics, or the formula which we will use to calculate the statistic here, the formula is t is equal to di bar upon capital S upon square root of n, where di is nothing but the represent the difference of the observation before and after. Okay, so for example we are given the two observations. This is the before providing some extra input, and this is the after providing the extra input, and on the basis of that we have a reading. So if I say that this reading is xi, this reading is yi, then this difference is denoted by di. So in the numerator we have an average, that is what is di bar. Di bar is basically summation di upon n, and capital S square is basically represent the like what you say, the sample variance. It is denoted by 1 upon n minus 1 summation di minus d bar square, right? Or in certain books they are using small s square as a formula for the sample variance. So but the relation between capital S and small s is small s square represents summation di minus d bar whole square. So here we are dividing it with n, and in capital S square we are used to divide it with n minus 1, right? So the relation between them is s upon square root of n. This is equal to small s upon square root of n minus 1. Okay, because if we just look at this relation, then we come out with this particular relation that I multiplied with n minus 1 and I multiplied with n, then we have a relation that s square into n minus 1, this is equal to small s square into n. Okay, because this particular value will remain same. Okay, so on the basis of this we can calculate this t statistics, and after calculating this value we compare its value with the t at 5% level of significance and n minus 1 degree of freedom, where n represent the sample size, right? So this is the formula we are going to use. Now let us come to the activity part. Okay, so for the activity we are considering this particular data. So suppose that this the very first column represent the roll number of the student. So I have included the data of some of the students whose CA2 and CA3 marks are given here. And in CA2 it is a simple subjective test was conducted, and CA3 is a test which is conducted on the basis of certain activities. So we want to see that if we have changed the pedagogy of the examination, then either the result is the improvement of the performance of the student or not. So for that particular sake we need to perform the testing of hypothesis. But if you just look at here the data size, then we are having a data of around 140 students, all right, and their CA2 and CA3 marks. But because we have to apply a peer t-test, and peer t-test is a basically small sample test, so firstly we need to consider small sample. So we can choose any sample size where the size is less than 30. So let us suppose that we are considering the sample size be say 25. Suppose I'm going to choose the sample size as n equal to 25 here. Okay, so firstly we need to choose a random sample of size 25. So we are going to use a command of a random number. Let us suppose I'm choosing a command of random between. So because we are given a number between 1 to 140, so I want to choose a random number between 1 to 140. Okay, so this is one of the observation 48, but I need a 25 observations. So I have started from box number 2, so I need a 25 observations. So let us suppose that this is the 25 observation. So because we have used the command of random here, so I simply copy, because if I made if I refresh this part, then every time we will get a different value here. Okay, because the command is running here. So I've simply copied this data. So these are the actual value. Now every time if we refresh this part, you will find out there is a difference in this data. Okay, so I simply remove this. Okay, so for random data we can use this particular command. Okay, this is the command which is used to choose a random sample, right? Because we are using the command of simple random sampling, the first step is we need to choose a random sample. Okay, control Z. Okay, okay, now my sample size is changed, so let me firstly I delete this one, because every time we come out with a different values only. Okay, yeah, so this is my sample. Okay, so now on the basis of this sample observations, I need to fetch the data of CA2 and CA3 marks. Okay, okay, again it will change. So because the command is running here, I need to copy this data and paste as a value. Okay, because otherwise every time it will change its value. So let me paste here, but I need to use the command as a value only, so that this particular part, you can see here again the value change. Okay, so now I'm going to delete this data. Yeah, so this is my sample observations. So now based on this sample observation, I'm going to fetch the data of CA2 marks as well as CA3 marks of the student. Okay, so to fetch this data, what I need to do, I need to look at this particular value and I need to fetch the information from this particular table, right? So I'm going to use the command of VLOOKUP. And what I look up for, I am looking for this value from which table. So for that I'm going to select this table, control shift down. We use this command so that we can cover all the but I don't need the last row, so I'm just considering up to 141 rows. Now out of these 3 columns, I'm interested in, firstly I am interested in CA2, so I'm interested in second column. Okay, so the first one is, what is the lookup value? So the lookup value is 54. From where I want to look up this value? From this table which containing these 3 column, but out of these 3 column I'm interested in second column only for CA2 marks, right? And what kind of value you are expecting? I am expecting the exact match, right? So I use the command as a false and now enter. So we'll find out in roll number 54. If we see here, roll number 52 for CA marks is 25 in a first C, and in second C 25, in third C marks is 8. So now I need to use the same formula for the next one also, but this time I am looking for, so you can either copy paste the previous formula, the only difference is we need to see the value of third column only. Okay, so I'm again writing the same formula. I'm looking for 54. This is the table. I'm control shift down command we use, but I need up to 141, and then this time I'm looking for the third column and I'm expecting the exact match. Right, so you can see here for roll number 54 in CA2 25 and CA3 8 marks are there. So now I'm going to drag this formula so that I can get the value for rest all other roll numbers also. Okay, but this time we are not getting value for roll number 18. Is there? Yes, it is there. Roll number 12, it is also there, and roll number 23. Okay, sometime there is some formula, there is a problem in the formula. I can rewrite this formula again. So this is VLOOKUP. So I'm looking for 18, and the table array I'm looking for the same, but this is 141, and I'm looking for column number 2 and false. Now we are getting this value. Okay, fine. And for this one I am copying this formula, paste it in the yes, I'm paste it here, but this time I'm expecting column number 3. Right, we are getting this value. Okay, so this time again, okay, let us rewrite this formula again, because sometimes there is some problem in the formula, but although with the help of this formula we can get the value, sometime it shows some error, but in that case we can rewrite this formula again, not a big deal. So this time I'm expecting 141, array number 2 and false. Yes, this time we are getting the value. Okay, and now again I copy this formula. You can see here when I again copy pasted this formula, then it is working, right? So it means that sometime it happen. Roll number 12, 3 and 16, yes, is fine, and roll number 23, 1 and 12, although I know this value, but I want to get this value through this particular command only, because sometimes we have a very big data, then it is a difficult job to look out this data from this column only, right? So what I am looking for 23. So again the table is started from here, control shift down, but I'm looking for 141, column number 2 and false. Now this time we are getting the value. Okay, basically I think I need to add here a dollar sign, so that the starting point will always remain same, right? I think that may be the issue, because every time I need to look at this value from here only, right? Because when we drag the value, then for example if I can look at here, then its value started from A3, but I need to look at from 2 only. Okay, so now if I drag this value, then we'll not getting any kind of error, I think, right? So now we are getting this value. Okay, so this is the sample observation CA2, CA3. Okay, so now there are two ways. If I want to calculate it manually, then what is the process? I need to firstly calculate di bar, that is where di represent the difference. I need to calculate the sample variance, we need to calculate square root of n, and then we can get the value of t statistics, and we can compare its value with the t only. This is one of the way, right? Let us try to do it manually, and then we compare it with a direct method also. So let us suppose that this is our x, and say this is our y. So now firstly I'm going to calculate d, which is equal to x minus y, right? So I'm using the command here, this value minus this value, so we get the first term, and now I drag this one so that we can get the difference for all. So this is the value here for dA. And now if I calculate the sum, because I need to calculate di, basically I need di bar, so I can use the formula of average as well, or I can calculate sum also. So we can get the value as a negative. So if I calculate mean, so the mean value is the average of, this is equal to the average of started from here, control shift down, but I need one less, say I'm considering here 26. Okay, so average comes out to be minus 3.3. Now for variance, either we can use the direct command, or I can firstly calculate d square. So this is equal to the square of this number, so if I drag this and now I calculate the sum, I simply drag this formula, so we can get the sum value also. Okay, so there are two ways to calculate the variance. One is the formula of small s square as this one, right? And the another one is we can also write s square as 1 upon n summation d square minus d bar whole square, right? So with the help of this I can calculate small s square, and then with the help of this relation I can calculate the value of capital S, that is s square upon n equal to small s square upon n minus 1. So the value of capital S square will be n time s square upon n minus 1, right? So we can use this formula. Okay, let us try to calculate this, and then I'll compare this particular value with the direct method formula also, right? Okay, firstly I'm going to calculate the value of the variance. So basically we get here 1491. If I calculate the value of small s square, this is equal to 1 upon 25 time dA square comes out to be 1491.25, 1491.25 minus d bar. D bar, that is the mean, it is minus 3.3, its square, minus 3.3 its square. So if I calculate this value, okay, let me calculate from here. So if I divide it with 25, this is equal to this number divided by 25, its value is 59.65. so its value comes out to be 59.65, and here its square is 1089, so it is 10.89. So if we find out the difference of these two, we can use the calculator as well. Either I can use it directly in Excel also, but let me show you here the calculation part, so that in both the way we should know that how do we calculate this, right? So we have a 59.65 minus it's a square of 3.3, so I'm writing 3.3 bracket close is square, so its value comes out to be 48.76. so 48.76, and if we take the square root, then it will gives us the value of s as well. Okay, or I can calculate the value of capital S square as n s square upon n minus 1. So what can I do? I multiply it with 25. 48.76 divided by 24. So if I multiply it with 25 and divide it by 24, so we can get the value of variance as 50.79. so this is the value of capital S square, that is 50.79167 approximately, right? So this is the value of S square. Okay, now I'll show you this formula variance also. If I directly use the formula variance, then what do we have? So we can use the command of variance sample. Okay, if I need the value of capital S here, then I use the formula variance dot s. If I need the value of small s here, then we use for population variance, right? So in this case I need to put the value of s from here to, I need the value up to 26 now, so I'm considering here up to 26. So you can see here the value is 50.79167. This is the same value which we have calculated here. This is the value of variance, right? And d bar is already known, so if I want to calculate the value of t statistics, then the value of t statistic comes out to be the value of t statistic comes out to be d bar upon capital S upon square root of n. So this is equal to, d bar is minus 3.3 upon capital S is square root of this number. So if I calculate the square root of 50.79, I find out its square root, then its value is 7.1268. 7.1268 and multiply by, now square root L now comes in the numerator, it is 25, so it is minus 3.3 into 5 upon 7.1268. So basically I need to take the reciprocal of this number and multiply it with 3.3 and again multiply it with 5. So its value comes out to be 2.315 with negative sign, basically minus 2.315. Yes, 3152 approximately. So this is the calculated value of t statistics, right? So you can see here this is the value of t statistics. And now what is n here? Because here we have chosen n equal to 25, so the degree of freedom will be n minus 1, that is 25 minus 1 is 24. So I need to check the value of t at 5% level of significance and 24 degree of freedom. Alright, so if I check its value for the right tail for 24 degree of freedom, this is the 24 degree of freedom and 5% level of significance for one tail. So this is the case, so this is the column we need to refer, this is the column we need to refer, and 25 degree of freedom means 24 degree of freedom, its value is 1.711 with negative sign because it is symmetric, so its value is minus 1.711, right? Now if we just look at the result, so this is the calculated value of t, and because we have applied here the left tail t-test, so left tail t-test means that in this case this is the region of rejection and this is the region of acceptance, this is the region of acceptance and this is the region of rejection. So we'll find out here, because the value minus 2.33, because this is the critical value, minus 1.7, its value is 11, minus 1.711, this is the critical value, and because the calculated value is minus 2.3152, definitely it falls in the left hand side, so it means that this value falls in the rejection region. So rejection region means that the null hypothesis rejected, null hypothesis rejected. So null hypothesis rejected means that alternate hypothesis accepted. So what does it mean? That it means that this is accepted. So what does it means? That there is a improvement in the result if we have changed the pedagogy. So this is what we can conclude here, right? So this is the result we have got here when we have calculated manually. But now let us see that how can we use the command of Excel to get the same result, right? So in this case we simply move to the option of data, and then we can use this option of data analysis. In my last video I told you that if this option is not available, Then you can go in the option of files, you can choose the option of more options, and you can choose the option of add-ins. You can choose the option of add-ins, and then you can click on the option of go, right? And you need to add this analysis tool pack. I have already added, that's the reason this option is visible to me, right? So then I can go to the command of data analysis here. In the data analysis I need to select, because I'm applying paired t-test, so I can go for t-test paired to sample for means, and then click OK. In the first variable range I need to click CA2 marks, control shift down, and in the second I need to consider CA3 marks, control shift down, but I need the value up to 26 only, right? And alpha is 5% level of significance, and I want to see the output here, you can say somewhere here only, right? So if I click OK, then you will get the output here. So you can see here whatever the manual calculation we have done. So and this is the mean of the individual data, that the sum of this one and the sum of this one, what it is come out to be, it is given here. Variance is given, sample observation is 25, degree of freedom is 24, t statistics comes out to be minus 2.3152. so you can see here t statistic comes out to be minus 2.3152. you can see here the same value we are getting here, and a t critical value, if we choose the 5%, then its value is 1.710882. so it is 1.711 approximately, right? But because it is a left tail, so we need to consider negative sign. I told you that generally it will gives us one-sided, that is right tail only. Okay, so for left tail we need to make some adjustment here, so in this case we need to consider negative sign here. Okay, so we can conclude this data. That means with the help of this command we can directly get all these calculations, so there is no need to do perform d or d square. So by choosing only these two column only, it will directly gives us this particular output of the data, but the rest part is the conclusion that we have to draw on. So what do we get from here? So we are getting here that the t statistics value is 2.3152 and the critical value is minus of 1.710882. so because the value falls in the region of rejection, because now this time this is the value 1.710882 with a negative sign, and because minus 2.3152 it falls in the left hand side of this particular part, so this is the region of rejection. This is the region of rejection. So what do we conclude from here? That null hypothesis is rejected, right? And hence we can conclude that yes, if we change the pedagogy of test, then the result is the improvement of the performance of students. So this is what we have learned from this particular activity, that how can we apply the peer t-test on a set of data if we are given the same set of student but with two different observation. It is not only for the student, we can consider the data of anything where we want to compare that what is the effect of a certain thing before and after, then we can apply peer t-test. Basically peer t-test is applicable when the data is dependent, it is not independent. We are considering two different observation of the same set of the data. Okay, I hope you will understand the concept what we have done here. So if you need further any kind of clarification or any doubt here, then you can post your comment. I'll try to provide you the solution of the same. Thank you. Have a nice day.